Welcome to the first video of Unit 7. We are going to compare the three different kinds of chemistry compounds. So we talked about metallic and ionic compounds in Unit 6. We talked about metallic very briefly. We talked about ionic much more extensively, but let's just review those. First of all, what are these different compounds made of? Well, metallic compounds just mean you have a bunch of atoms of the same element. That's going to be a metal element. For example, if you have a piece of iron, like an iron nail, it's a whole bunch of iron atoms. For an ionic compound, that means you have both a metal and a nonmetal. So, for example, sodium chloride, the sodium is the nonmetal. The sodium is the metal, and the chlorine is the nonmetal. Their electrons do different things. Again, something has to happen to the electrons in order for it to be a bond, and you have to have a bond in order for you to be a compound. So, when you have a metallic compound, all their valence electrons leave the cation, well, they leave the atom, leaving a cation behind, and they just float around, all through all the atoms, and that holds them all together. In an ionic compound, the cation gives its electrons to the anion, and the electrons stay that way. They never go back and forth, it's just one transfer, but then now we have positive charge and negative charge, so they stay together. So how do these things look? Both of these are solids. This is a sort of an amorphous solid. It doesn't have a regular structure. This one's a crystal solid, meaning that it has a regular structure. We call it a lattice. Positives, negatives, so on and so forth. They both have high melting temperatures because they're solids at room temperature. So how do you call these things? Well, for these, you just call them a metal. So if we have an iron nail, we just call it a piece of metal. For these, this is called a formula unit, meaning that tells us the ratio of the cation to the anion. So subscripts. We don't have subscripts in metal compounds. We don't give any indication of how many atoms are there at all. For the ionic compounds, we have subscripts. These ones are just ones, so you don't have to write them. And they're the ratio of the cations to the anions. Now, let's talk about covalent compounds. Covalent compounds are made of two or more nonmetals. So there are no metals here at all. Non-metals. So this unit, we're going to be talking about covalent compounds. We're going to focus all the way on that right-hand side of the periodic table where the nonmetals are located. The electrons in covalent compounds are shared. Nonmetals primarily make anions. Anions want to take electrons. Well, if this one wants to take and that one wants to take, they can't both take from each other, so they're going to have to share the electrons back and forth. These often are liquids or gases at room temperature, or solids with a low melting temperature. For example, butter. Butter is a covalent compound. It's an organic compound. All organic compounds are covalent, and it melts at a very low temperature, even if it is solid at room temperature. How are these things called? Now we actually get molecules. I harped on this last unit. There's no such thing as an ionic molecule. If you're talking about a molecule, you're talking about a covalent compound. So this molecule right here, carbon dioxide, that is actually called a molecule. And then the subscripts mean the actual number of atoms in the molecule. So we have an individual molecule that contains one carbon and two oxygens, and that's one molecule. And there's another molecule over here with one carbon and two oxygens. They have nothing to do with each other. So that is the subscript. It's no longer a ratio anymore. It's an actual number. Therefore, it does not have to be reduced. We're going to talk about that in a later video. Thank you.